Think we're live. We're live. Hey everyone. My name is Matt Rabel. Welcome to the Denver Java user group. So Greg isn't here tonight. He had a family event, so I'm filling in for him. And tonight we have foundational Kubernetes and container security with Chris Love. And as you might have known from previous meetups, we stopped doing sponsor slides and talking about sponsors because, sponsors aren't doing much, right? They aren't bringing us pizza or beer or anything like that. So we are working on getting back to in person, but we haven't had a whole lot of luck finding places to host us. So if you know of anyone that has a location, hopefully downtown or in the Denver area, please let us know and we'd be happy to talk with them and maybe work something out. And we're going to bring up Chris Wona here. Sorry, Chris, from the older Java user group.
Great. Yeah. So we've been, we're in the same state, in the same neighborhood, and we traditionally had been sharing speakers in the past because they travel long distances. But since we're virtual, we've been combining together. And we just want to thank Rule 4, Emerging Technologies and Cybersecurity in Boulder. We've been having some live meetups there as well. Thanks, Matt.
Thanks, Chris. And so, yeah, we have Chris Love tonight, and Chris has quite the bio. If you've seen on the meetup page, he's a Google Cloud certified hybrid multi-cloud fellow and co-founder of Lionkube, and over 25 years of software and IT engineering experience. And you can read all about his credentials. That's fun to read, but really, you want to know what he likes to do, right? So he loves skiing, volleyball, yoga, and any outdoor activities that come with living in Colorado. So he's also a practicing martial artist for over 20 years. So welcome, Chris.
Thanks, Matt. Let me take these things off. I appreciate the introduction. Give me a thumbs up if you can hear me okay. Really appreciate joining you tonight, and hope I can share just a little bit of information about pod security and containers and Kubernetes and all that good stuff. So let's start off. As Matt mentioned, I'm Chris Love. I wish Google had named my certification just with a couple less words. So hopefully you're here to learn a bit about security. It's, with the incidents that have happened recently, it's kind of in the forefront. A certain car company that you can get ride shares from decided to allow their system to be hacked. And it's really becoming paramount. There's studies around security, and tens of millions of dollars are, if not over $1 billion a year, are wasted in terms of just when people get into your systems, as well as downtime is incredibly expensive. And that's often what happens when sites and systems get intruded on. So we're going to cover three different things. We're going to cover containers, the pods, and as well as the nodes, because really everything for me starts with your container level security. If your containers aren't secure, up to date, etc., you're starting off on a bad foot. Next, you've got the pod, which of course is the basic building block of Kubernetes. There's a bunch of configurations within the pod that we're going to go through. And then we're going to talk about the nodes and securing the nodes in the control plane. The control plane being what was previously referred to as masters. It's your API server. It's everything else. And typically, most of the hardening and securing of your control plane is by your cloud provider if you're running something like EKS or GKE. So let's start off with containers. As I mentioned, it's really the cornerstone of your security. So believe it or not, it's 2022 and people still aren't updating their images. We've had multiple issues with Bash or curl or, memory serves me correctly, Log4j, for instance, with Elasticsearch and other programs that used it, really come under, or we have had tremendous issues where we have to not only be able to update our images consistently so that the latest software of, say, Bash is running on them, where you're not able to, where we don't create security holes by having it running. But also, we need to be able to deploy out our systems very quickly so that when Elasticsearch needs to be updated, we're not looking at hours upon time to update Elasticsearch, but we can do it hopefully within an hour or within minutes. And because of that, what we want to do is, or in order to enable quicker updates, we want to and also reduce the attack plane or the attack surface area. In other words, how much can be attacked, right? We got to reduce the container artifacts. You can do several things, including multi-stage builds. You can run distro lists, and you can also run container-specific images. And let's go through each of those a bit. So part of the problem with containers, or what we often get, is that we'll build our software within the container, and then we'll keep the SDK around when we build it. Now with JDK really doesn't apply, but we're working in other languages such as, say, Go or C++. And instead of leaving your SDK and your compiler in your system, you can run what's called a multi-step build. Basically, in the same Docker file, you've got two from statements. You can see on the slide, we're building from Golang 1.7. We set up our work directory. We do a Go build. That, in essence, will build our binary for Go. Next step in the multi-step build is the building of the container that's going to house our binary. We're using Alpine Latest. We run and install the other certificates. We set up our work directory. We copy in everything from the myapp directory, and then we've got the command, or rather we copy in the myapp binary. So that allows us to not have the Go SDK inside of your container, and you're basing your container, or the container that you deploy and create is from Alpine Latest, which is one of the thinnest Docker images out there. Next thing we brought up was distrolist. Distrolist was created by Google Container Tools, and by Google, of course, or it's hosted in Google Container Tools, and it's provided by Google. Distrolist images don't contain all the bulk. It doesn't have bash in it. It only has the specific specific libraries that you need to run whatever you're running. For instance, if you're running Java, it'll only have the necessary items for the SDK. If you're running Python, it'll only have exactly what you need for Python. At times, you don't even have PS. So it's a bit of a pain in the butt to diagnose problems, but when you get a little bit more, or when you reduce your control plane or reduce your attack surface plane, you limit your risk footprint. Secondly, using container-specific images. Don't use the full Debian image as your base image. Use Debian Slim. Use Alpine. Or Red Hat has their own container-specific image. Or just use from scratch if you can. That way you have absolutely nothing in your image except for the binary that you need. Let's go. Well, so I got confused by the slide here. So again, we have another multi-stage build, but now what we're using this time is from Debian, the base 11. So instead of using Alpine, we're now switching distrolist, and actually the distrolist image is actually thinner than Alpine. Some other things: don't run as root. That's a big thing. Most companies, or if you're looking, for instance, if you look at the Nginx image, at least previously, a lot of other things are running as root, meaning there's only one root within a Linux system. There's one user's root. Doesn't matter if you're in a container or you're on the host system itself, you're still root. So if you're able to move from the container into the host operating system, which is very, you're running into certain scenarios, you're able to do that. For instance, if you mount a file system, part of a file system, and it has root level files on it, you're actually able inside the container to attack those files. Run trusted images, which is provenance, container provenance. Don't run something necessarily out of Docker Hub. Bring it in to your own container registry and house it there. That way, if Docker Hub gets hacked, you're not pulling in inadvertently images that have been modified. And as I said, just update your containers. I know I talked about it previously, but we've worked with so many companies where they're running into problems where they've got 2-3-year-old images that are still running in production. And there's so many CVEs filed on those images, it's not even funny. So also look at screening your containers. So we need to know when to update your containers. That means we need to screen containers. Most of the registry services nowadays provide automated screening tools. And you're able to see, hey, I need to update bash, or I need to update curl or wget, what have you. And if you can tie that into your CI/CD, and or if you do regular CI/CD builds on a routine basis, you'll pull in those new dependencies. Now, the tricky thing is that these services exist. Most everybody has them. Nobody reads the dashboards. So again, make sure within your organization, encourage your bosses, or if you are the boss, set aside time for your engineers to update, get a good stable CI/CD system, but also making sure that you're looking at the dashboards and or pulling those in to some sort of report so that you can see, okay, every 2 weeks, this is what we need to rebuild and redeploy so that we get rid of the CVEs. All right, let's shut down this slide deck for a second and take a look at some stuff with containers. So one of the things that I've got, and I got to pull that page up again because I think I closed it. Let me do that real quick. One of the tools that I always recommend is Hadoolint. Hadoolint is a linter for Docker files. And I've often integrated this right into CI/CD where you're able to get linting done on your Docker file so you know what's going on. I've got an example that I'm going to pull in here. That's unlinted, and we'll start there. All right, so let's clear this and then paste it into our linter. Not that one, that one. So a few things. It's saying that we're not using a version of the explicit image. In other words, we're not saying node 12, node 14, node 15. We're also not pinning versions, and we'll go into pinning versions. In other words, I want to install Python 3. I don't want to just install Python 3. A lot of different reasons between compatibility issues, but also just you want to have fine-grained control over what images you're installing. As well as it says use workdir to switch directory, and we've got some other improvements we're gonna do on this Docker file as well. So I'm just going to fold into here the linted version. Actually, you know what? I'm going to pull it up right here. That's the wrong one. So let's go through what I've done to fix this file. So first off, we're doing from node. And what we're setting it to node 18, specific Alpine version. Next, we're adding some labels so we can actually add a timestamp to this, add a branch version, a versioning version to this so that we can track it down during a release process. One of the things we like to do is add the CI/CD release version as well as the git SHA into a label. You notice we talked about pinning the versions. So we want to install G++ 10, right? We're also installing a new package, which is Go SU, which I'll go over here in a moment. We're also doing no cache on these. So if you set up something as no cache, it won't stay on the container inside of Alpine. It's an Alpine specific tool. It won't actually reside inside the container. Once the container is built, Alpine will actually clear it out and remove it. So what we're doing here as well, one of the other things you want to look at is, as I mentioned, don't run a container as root. So in other words, don't inside the container, you start a process, you run entry point or you run command, natively your process is starting as the root user, which of course has super user privileges. So we're adding a user node and the group node. Secondly, we fixed the copy statement we had before, or we fixed the CD we were using. Now we're using workdir. And we're also correcting, actually should be a chown instead of chmod here. Let me fix that bug real quick. All right. So we're setting the user correctly over all the files so they can read it. And then the entry point, we used to have a command. Now we have an entry point and command. A little bit of style points here, not really super important. But the entry point, we're setting that Gosu is going to switch over to the user node and run the binary node. That's what these three commands mean. And then the command is going to run source index.js, which is our node application. Now we can, with an entry point, if you're not familiar with them, with an entry point, what you're able to do is it always runs the node command. Whenever you fire up the container, there's a way to override it, but by default, it runs that. Then as the argument, it accepts the command. So you can easily override the command. For instance, if we did a command on either in a pod manifest or on the command line with Docker, you could override the command very easily on the command line as a command line argument. So again, we've pinned the versions. We've added a new user to run node under. We've set the file permissions correctly. We're tagging which version of node we're using specifically. And from that, we've improved the security of this container immensely. The big thing really to me is that we're versioning and we're labeling and we're not using root. Awesome. Let me restart this and get back at it here. So next, let's cover the pod. If you're not familiar with pods or Kubernetes too much, a pod is the basic building block that a Kubernetes cluster hosts. You've got stateful sets, you've got deployments. Each of those components contain pods. A pod can house one or more containers. So basically, you've got an API component. It's called a pod. You need to put something on a Kubernetes cluster. It's going to deploy a pod out for you. If you got a deployment, it'll create a pod entity for you. So by default, this is an interesting thing. So a pod can actually access the API server of Kubernetes. And that's because at times a pod needs to control and automate the Kubernetes cluster. There's lots of different pods within your control plane, as well as, say, networking pods or operators which install, say, databases that need to talk to your API server. But by default, the service account token for that pod is auto-mounted. In other words, the service account token that you use to authenticate with your API server. There's one line of YAML that needs to be in virtually every pod definition, which is auto-mount service account token false. And in other words, you will not get a service account token that's auto-mounted then. And it reduces your security profile immensely, or risks. The second thing we want to talk about is security context. So as I mentioned, you're able to set up values for root and other users within your container. But also what you want to do is denote the process IDs that are being used for that user and that group. And you're able to set within the YAML definition of a pod, so within the pod, within your API definition, which is often in YAML, you're able to set the user, the group, and the file system group that they're using. File system group is if the process writes a file, what ID is that file going to be written as? Also, use security capabilities as needed. So within a within a pod and within Linux, as in general, you have something that are called capabilities. You can actually man capabilities. And what you'll get are different cap commands. And those commands are, so root has everything, is the easiest way to put it. Within the Linux kernel, you have subdivisions of that everything. For instance, capabilities to mount a file system, capability to restart a Linux server, and a bunch of different other capabilities. So if you need a pod, for instance, to adjust networking, which actually is a pretty typical thing within the Kubernetes cluster, a pod needs to have the privileges to adjust networking so that when a new service is created, the either IP tables or your BG or other rules within your network, within Linux kernel network, are modified so that we got new IP addresses created and we got new routing tables modified. That's actually done within pods within Kubernetes. And for that, they need cap_net_admin. Now, don't add these privileges if you don't have a pod that's kind of the operator pattern or a controller pattern where it is controlling the Kubernetes cluster, or you've got an operator that's doing some fun stuff that's, say, mounting file systems or other random things. But use these quite infrequently is the best way to say it. Also, there's a stanza to drop all of your capabilities, and then you add back only the capabilities that you need. So let's go through a bit of the YAML to do that. So let's first take a look at the pod security context YAML. So what we've got here, of course, is a pod. And this is the pod YAML definition. If you notice, we've got the auto service account token is set to false. And then you've got another security context. And you'll notice we have containers defined down here. And I mentioned that you can have multiple containers. So this security context applies to all of the containers that are running within this pod. You have run as user, so there's your user ID. You have run as group, there's your group ID, and then you have a FS group, which of course is the file system group there. You also have FS group change policy, which often volumes are root. So if you have a persistent volume claim or a PVC that's being mounted by your node and then mounted into the pod, that'll often be mounted as root. Well, within a group policy change, what you're able to do is it's changed from the root ownership to the correct IDs when it is root. And that'll help you that processes can actually write to the correct directories. And then the rest of the pod is described as needed. So if I've got a running Kubernetes cluster here, so I'm gonna, and let me have you save 60 million years in your life. Alias kube control to K. So we're gonna create minus F01. Okay. All right, it's up and running. So we're gonna exec into it. So we're able to actually get a command line running on that pod from my command line, which is remote. All right, there we go. And now let's do an ID. So instead of root ID, which is 1, now we have correct UID, which is 3042 and 4042 and different groups. So those are all the IDs that we set up within the pod definition. All right. Now we're going to go through the escalated example, which actually I'm running kind in the background, which is running Kubernetes within a container. So it puts all of the controllers and networking and everything within a single container. And as I was working on this demo, it was I ran into the situation where you can't run escalated pods within kind, which was kind of interesting. But let's go through the escalated pod security capabilities. So as I mentioned, previously we had security capabilities that are for the entire pod. Security contexts are only for a specific container. So you notice the capabilities, we're dropping all here. So we're removing all capabilities to start off with. And then we're adding back netadmin and BPF. And as I mentioned, with the one difference within Linux and within Kubernetes is that within Linux, the call is cap_netadmin. Within Kubernetes, they decided just to shorten it down to remove the cap underscore, and you've got that capability. And if you look at a CNI provider, which is a container network interface provider, which is the pods that network and allow nodes and pods to talk to each other and allows pods to have IP addresses and all kinds of other fun routing stuff within a Kubernetes cluster, they'll have these capabilities. And they'll also be running on the host network. And that's another thing that we want to make sure is we've got actually two different networks within a Kubernetes cluster. The first network is the network that hosts all of your nodes. The second network is what's called your pod and service network. That's a different CIDR range, and it's separate from your node network. Well, if a pod needs to operate on the host, needs to control the host somehow, then you want it to be part of the host network so it can communicate with specific ports and be able to operate in that function. So you don't want to have pods running a host network typically, unless they're helping control your system. All right, that's pod demo. Let's get back to the slideshow. So next, let's move on to some node security. The nodes are the servers within your system that are housing all of your pods. So one of the big things that have been talked about, and I'd say within the last 5 years, is using immutable operating systems. Within Java, we have, immutable is part of the language. And it's the same type of functionality within an operating system. You cannot change files on the operating system. You cannot overwrite files. And what that means is that you have everything that possibly can be read-only is mounted as read-only, even to root. So even root can't override a file. And Kubernetes gives you the interesting capability of being able to completely replace a node. And that's typically the pattern that you want to use in upgrades, is that you are not updating Debian to redeploy Kubernetes. You are wiping the server clean, or in the cloud, you're creating a new VM that has a completely new version of the operating system. And using a mutable operating system, gives you that capability. All the big cloud providers have it. Red Hat has it now. VMware has their own. It's pretty much, I would say that I don't want to run utilities to update my operating systems now. I want to just have an immutable operating system there. I just throw away the node, spin up a new virtual machine, pods can go back on the node. And as I said, Kubernetes is built around that capability. Second thing, a pod, if you don't have the correct resource limits, can basically do a denial of service attack against your own cluster. And the way it can do that is running away with all the resources. You have the capability of setting resource, CPU, disk usage, and memory limits at both a pod level and a namespace level. So you want to use resource quotas and resource limit definitions within the pod and within your namespace. which means you need to profile your pods. You need to profile the amount of memory that is used within the system. There's many different tools out there that'll help you do that. It's a little bit more time constraint. Now, if you don't profile your pods, what you do is you set up that within a namespace, you can only use you can have max resources. That way, you're only going to override a namespace, and the namespace is typically distributed across multiple nodes, so you're not going to be able to really, override your system or overrun your system with runaway CPU stuff. So let's go through a bit of pod definitions with limits. So the section that we're most interested in now is around the resources. We have multiple different definitions for memory for the sizing. We can use, for instance, with CPUs, you can use 84 meg, or you can just do 1. And I've got a typo in here, which is awesome, because I'm missing the correct stanza for CPU. I'll fix that. All this will be up on a GitHub site. I'm about to push super tiny set of YAML and a Docker file for you folks. So we're able to set the amount of memory, and so requests for memory and CPU, requests for ephemeral storage, and requests for CPU as well. It's basically limits. You profile your images. You have different types of QoS, which is quality of service types, where you can do maxes, you can do bursts. I won't go into all of that. It's pretty well documented within the Kubernetes site. But basically, it's just different use cases for how you're going to guarantee quality of service within your Kubernetes cluster for a specific pod. Now let's go back into this, and this is going to transition into the next section. Within Kubernetes, there's functionality of RBAC, which is role-based access control, where you're able to define service account names, and you're able to find roles and profiles. And basically what it does is it sets the level of access that a pod has to the API server. And it might be none. So you may create a new service account and not define any roles that are joined to that service account, and then the pod has zero access to make API server calls. What you want to do, though, is you want to have a unique service account name for each of your components within a cluster, whether it's stateful sets, deployments, pods, jobs, what have you. Each of those want to have a unique name, because then you can disable it and you have more fine-grained control. So remember that we're gonna, once we start covering more information in RBAC, we'll go back through how to create a service account, a role, and a role group. All right. So pod networking, as I mentioned, and we're not going to go through network policies in detail, but we have don't run pods on the host network. Run them on the pod network if you can. We also have network policies within pod networking. It's actually not really widely used. I would say service mesh is actually more widely used for network control. But in between namespaces and in between pods, you can create routing rules. You can create ingress and egress rules that allow you to say, no, this pod can't talk to the internet. It can't talk to google.com. This pod can talk to google.com, or it only can talk to redhat.com, can't talk to google.com. As well as mutual TLS, if you're running in an environment where your data must be encrypted and conversations between microservices must be encrypted, you're going to want to run mutual TLS. As I mentioned, service meshes like Istio and others provide mutual TLS out of the box. That's one of the big benefits of running service mesh. But only use it if you need it. It's just, if anybody's ever messed around with TLS, it is non-trivial, is the best way to put it. Secondly, secure your API server. Within all the cloud providers, you typically have to check a checkbox and or set up your networking correctly, where you're going to need a bastion or a VPN, where you're going to want to put your API server behind the firewall, or I'm sorry, behind a private network at least, and possibly a firewall as well. GCP and AWS all support this functionality where you'll have a private and public type networking. Your private network will host your API server location. Your nodes will be able to talk to your API server, of course, because they've got the kubelet needs to communicate back to the API server all the time. But you definitely don't want to run a publicly exposed API server. There have been CVEs that have come out where we've had security bugs in the API server. One version was released really quickly and quickly removed, where they completely turned off authentication on the API server level. So you're definitely going to want to put your API server behind there. And it's one of the most critical things that a hacker can get into is get API server access, because as you noticed, I did a kube control exec, which is I go into any pod. Well, a person that has access to your API server can just bounce around in between pods if they get access to it. And that's, having a hacker get inside one pod's a bad thing. Having a hacker with the capability to get inside of everything that's within a cluster is definitely another bad thing. So again, protect API access. You want to shut off that token all the time that I talked about. But when appropriate, you're going to want to create the RBAC rules, as well as give out admin kube control access appropriately. There's two really, mindsets with giving out root privileges, because basically giving out admin kube control privileges is giving away root to a Kubernetes cluster. Those are the keys to the kingdom, as they put it. You want to follow the model that your company has. In some companies, everybody has root access, for instance, and I'm not sure if Spotify still has this, but every user basically has access to production and access to everything in production. Now, what you want to do is follow that policy, or if you're on the other side of the fence, often DoD is very much like this, you're going to want to limit, say you have different namespaces that are for different engineering groups. Even in development, you limit their access just to that namespace. Within majority of cloud providers, you're able to link in their cloud ID or their SSO ID that they're using to log into the cloud directly into their RBAC profile for the user. All right, next, so we started talking about RBAC in our pod demo. Now let's talk about it a bit more. And let's walk through some of the code. And admittedly, RBAC is complex. I think I could have written 2 chapters in my book on RBAC, and I decided to cover it in a few sentences or in a few paragraphs instead. But it is complicated in terms specifically of debugging. So as I mentioned, we had a service account on the pod that we had previously. So here's our pod YAML down here. You'll notice at the very bottom of the screen, we have the secure service account name, which is network SE, and that now is applied, or the service account's created by this API definition for the service account. So from there, we have a role. Now, I would say the role is the most complicated component of RBAC definition, because within the role we have rules, resources, and verbs. So the groups, if you notice, we have an API version here on this role. That is actually your API group. So a pod API group is in the core API group, so you don't actually have to list it. You just put the 2 quotes. Now the resources is what is inside the API groups. For example, we have pods, we have deployments, we have stateful sets, are all, and I think a couple others, are all within the core API group. If you had access to create RBAC within a cluster, then you would have roles and service accounts and role groups and cluster role groups, for instance, would be the different resources that can be in the resources line in line 10. Now, the different verbs you can have are list, patch, get. So it's basically like CRUD, right? Create, read, update, and delete. Pretty much within REST. It's through gRPC, but they still have the same type of REST level functionality, and they have their own verbs that you can use. So what this defines, if we put all what I just said together, is that this role provides the capability to act on a pod, and you can list the pods, and you can also patch the pods. Now, this is a role, and we also have cluster roles. So a role is just within a namespace, while a cluster role is within an entire cluster. So typically you want to keep it to a namespace, but if you've got something that's doing work all over the cluster, then you create a cluster role. So we've got our service account, we got our role. Now the third definition that binds them together is a cluster role binding. So again, we've got the namespace definition, and we've got two references. We've got the subjects, which is a list of service accounts. So you can have multiple service accounts that have the same reference to the role. You can only have one role, though. So we had our network role, and then we had our service account that's bound into that network role. So the pod that had the service account defined now has the role privileges that were defined in that role binding. So the role, I'm sorry, other way around. The service account now has the RBAC privileges, and the role and the service account are brought together by this role binding. All right. So we're going to go, actually, I'm going to go back one slide. I'm just going to stop the slides for a second so I can go back to that slide directly. One of the things I talked about was debugging with RBAC. You're going to want to turn on your API server, or there's actually an RBAC log within your API server logs that you're going to want to enable. And what it'll show is X pod made X call into the API server and was denied. So if you're having problems with a role binding or a group or a role permission, you can actually read in the log statements that this is what you need to do. There's a couple other tools out there. One was by Jordan Leggett, and I'm not sure if it's still maintained or not, but it basically created an audit profile for you of what the pods are using and not using. But your API server is going to be your friend when you're debugging RBAC, where you're not getting your role information correct. I will also mention that different blends of Kubernetes distributions, specifically OpenStack, will have different verbs that are not part of the regular verb library for RBAC. They have, I can't remember them off the top of my head, but I ran into a situation where an operator needed a different set of verbs that weren't included in the standard distribution of Kubernetes. So if you're running on something like OpenStack or, OpenShift, not OpenStack. If you're running on Red Hat OpenShift, you're definitely going to want to look at that consideration. All right. Now back to the presentation. Cloud-based considerations. So we're going to have a cluster count. So your cluster is going to have to control cloud resources, right? So Kubernetes cluster is going to create a load balancer. And you want a specific account, a service account created within your cloud for that Kubernetes cluster. For example, if you create a GKE cluster without a specific service account, it's actually going to use your service account. And if you have permissions to create Kubernetes clusters, that means you just created a Kubernetes cluster where the pods have the capability of creating Kubernetes clusters. So let me say that again. If you create a GKE cluster with your own account, it's going to bind to your account privileges, and then you're going to give away your account privileges to just about every pod that's on that cluster. And then we're talking about the pod accounts. So without something like, there's different tooling within GCP as well as AWS, we're able to do cloud level service or pod level service account bindings. So if you have a pod that needs to connect into a cloud-based database, you're going to give it a specific service account then that has capability of accessing that database, rather than allowing the cluster account to access that database for you. So your cluster account shouldn't be able to access that database. Your pod should be the only one that's able to do that. All the cloud providers have that capability where you're able to turn on more fine tuning where your service counts are traveled through. If you do that way with cloud resources, you're able to create IAM profiles specifically for that account. So if you have an application that needs to make S3 calls and store files in S3, you're then able to create a service account for that pod and then create an IAM role that allows you to write and read just those S3 files rather than giving it all the permission in the world to read your entire S3 bucket. So security automation as well is super important. Open Policy Agent is one of the ones that's really I encourage everybody to use. Open Policy Agent allows you to write policies that give specific guidelines and emission controllers or guidelines for emission into your system. So for instance, you can write a policy that says you have to pull an image from our private registry that has this path to it. And it'll stop, for instance, users from pulling in images inadvertently into dev that are from Docker Hub or their private registry. So what it'll do is when you make the kube control call or some system makes a kube control call to create a new deployment, there's a capability called an emission controller, and it controls the emission of objects into your API server and thus into Kubernetes. So if you define rules, for instance, you got to define what your user IDs, you've got to define limits, you've got to define, you can only use private registry locations. You can write rules within the Open Policy Agent to denote all of those things. Hadoop lint, we already went through that one. It can run the command line. There's a container for it. There's a web interface for it. It can definitely catch and prevent problems from a Docker file level. Multi-tenancy. So Kubernetes wasn't built for zero trust multi-tenancy. Frankly, containers weren't built for zero trust multi-tenancy. And there's zero trust and medium trust and no trust models. Basically, it's saying, is it okay for neighbor A and neighbor B to talk to each other? How much isolation do I need within my system? The thing is that if you're looking for multi-tenancy, the API server path, so the API server is a full REST server where you're making a REST call into /get///, right? So basically URI. It wasn't made where it starts off with the username or starts where you give it that type of tenancy information. In other words, I'm Chris Love. I'm making a call into only the API server components that are owned by Chris Love. Again, there's also some issues with container level and Linux namespace level isolation, where there's not full zero trust capability within running containers. There's some new container technologies, and also we now have the capability, and I should add a slide about this, to run an API server within a Kubernetes cluster, meaning you have multiple API servers running as virtualized Kubernetes clusters within a Kubernetes cluster. Now, you might be looking at me now and going, okay, why would you even want to do that? Well, you now have the capability of having multi-tenancy. What you can do is you can give team A isolated virtual Kubernetes cluster that's running inside of a prime Kubernetes cluster. And then you give team B another virtual Kubernetes cluster that's running inside a Kubernetes cluster. So there's a couple open source companies that are doing this. And there's also Apple runs this on site, and they're contributing to open source within that's hosted within the CNCF, which is the home for Kubernetes as well. So there's multiple different companies that are working on this. One thing that you still get into trouble with is networking. You have to have some form of highly customized network to have pure zero trust. The company's A pods and tenant A pods and tenant B pods still can talk to each other via networking if they get really creative. You need some form of network layer that is able to separate those. And typically within GKE or EKS, that layering doesn't exist yet. So also, why is there no zero trust? Components like CRDs are not namespace. The API structure, like when you create a CRD, and it's a CRD is a definition of a new API. So custom resource definition. So basically, I want to have a foo API object. Instead of petitioning Kubernetes to build a foo API object within your API structure, what Kubernetes folks did is they provided you the capability of defining a foo API object, and you create a CRD, and then you're able for foo, and then you're able to create a foo object. Well, when CRDs were created, they weren't namespaced. Thus, you create a CRD for foo, everybody can create a foo CRD. Also, just getting namespaces isn't namespaced. If you do a call to get NS, you're going to get all the namespaces, no matter if you have the capability of making that call. So let's recap. And I know that I'm right at about an hour. We've got a little bit more than that, but I hate it when speakers run over an hour. Personally, really start off with container security. Update your images, please, folks. Use Hadoop to lint out those Docker files. Look at pod security. Set up the IDs. You're not running your containers as root. Set a specific ID for your pods to run as. One note about OpenShift as well. You can't run, there's specific settings for those IDs. There's other things within pod security where don't run a host network, as well as if you're going to need a pod that has specific capabilities, definitely don't give them all the capabilities in the world. Just give them netadmin. Node security, don't put your API server open to the public. Watch your multi-tenancy. Use immutable images. Update. Now, I should add this to the deck as well. Upgrade Kubernetes. Don't get too far behind. Expect when you're using Kubernetes, it's worse than upgrading Python. They're going to release faster and more often, where you're going to need to upgrade Kubernetes a lot. So set up your system and set up your DevOps practices where you're expecting that. Also build your applications, build your Java apps, so you're going to expect the type of outages that Kubernetes gives you. All right. Little note about Lionkube. We're a Kubernetes consultancy. So we help out companies that need help with Kubernetes, whether it's looking at a cluster that they've set up that they're having challenges with. You need some more staff on hand that will help you out with Kubernetes challenges. you've got, you want to migrate over to Kubernetes, or if you're running Kubernetes now and you feel like you're spending too much money, and most people that are running Kubernetes are actually spending too much, we'll, just contact us and we're happy to help out there. Another thing, we're not doing Q&A because we're virtual. Thanks for attending. If you also follow me on my on Twitter and DM me that and my Twitter handle is right down there, Chris Love CNM, and DM me that you attended the JDUG. I'm going to be giving away a couple of free copies of my book, Core Kubernetes. So just follow me, DM me, or follow me, I'll follow you back, and you can shoot me over a DM or a message that you attended, and then I'm going to make a random drawing of a copy of my book and shoot it off to you in the post. Thank you so much. I very much appreciate the honor of helping out here and talking to you a little bit about Kubernetes security.
All right. Thank you, Chris. Appreciate it. And actually, we did get some questions in the chat, so
awesome.
Rattle them off here.
Let's go back to the Q&A slide, quick.
So there's some statements too. We can put the Q&A one back up if you want.
Statements are good.
So the first one is from Matt Henry. He said he was looking at the distro list version of the Paketo stack.
Yep.
Or Spring app. They recommend a step up from that for some reason. Amy Bionic Base. You ever heard of that?
Nope. Haven't done it, but I would take the word on that.
Okay.
So see what's it's more put it through a security screener is what I would say, and you're going to find out what actually needs to be updated within the distro. So that'll always give you a good idea of where you're at with how much stuff's running.
So we got another one, Bottle Rocket AMIs for the win. Have you heard of that?
It sounds like immutable operating system to me. I haven't heard about. Oh, we're talking about Bottle Rocket?
Yeah.
I'm not going to comment because I don't know exactly what it is. I think I might, but I'll actually not say anything, which is odd for a speaker.
Yeah, I don't either. All right, another one from Matt Henry. He was a popular guy in the chat. Will setting auto mount service account token false on the default service account solve the auto mount item for all pods, at least for that default service account?
So the automatic service account on the default service account, no. Hold on a second. I think yes, you can turn that off as well. So on but then if you do use the default service account, it's not going to auto mount the token. So it's a little bit of one or the other. So within a service account definition, there's a default service account, which you never should use. It's the default service account. So you're able to actually set whether it auto mounts or not. And so you can shut it off for all the default service accounts. But if you have another service account, and you should be using a different service account, you're going to want to then set it off there or set it off inside the pod. Your call.
Okay. And then a follow-up one, can a pod mount any service account in its namespace, regardless of that setting?
Yes.
Cool. He also said that Bottle Rocket was an immutable OS. So
that's right.
Thanks, Matt.
Good. Cool.
So, Chris, you got any questions?
No, it was a great presentation. I thought it was.
Thank you.
Yeah. To the point.
Yeah, as well. One question I had for you is, what do you think of Kubernetes secrets?
They're not secret.
Right. Like, why are they called secrets? If
we had to bring secrets in somehow, right? So you can lock them down by namespace. You can give them certain privileges, but you're still going to get cross-level capability, right? The thing they're not easy. It's not easy to rotate them either. They're an MD5 hash, which you just do. You just unhash it and you got the secret. So they're not secrets. But they needed some way to bring in passwords and usernames and certs into the Kubernetes ecosystem. So what you do is use secrets manager, and there's operators within Kubernetes that will take your AWS secrets or your GCP stored secrets, and it'll migrate it directly in to the cluster of secrets. And you're going to want to use that, as well as HashiCorp Vault has Kubernetes support as well. So you can use either an external Vault server or an internal Vault server and use that for storing your secrets, and it'll move them in. But yeah, it's kind of weird. But I think this is the reason that I'll give that they didn't do it. Kubernetes isn't a platform. It's not a solution, right? So it's a platform. It's not a secret solution. They would have had to bring and build in secrets management into Kubernetes if they want to do that. And they got a lot of other things to worry about, like scaling and replicas and scheduling, rather than bringing in secret management.
Yeah, that makes sense. All right. Well, that was
still, it bugs me too, though, man. It bugs me that they're called secrets and they're not secret.
I've used sealed secrets from Bitnami, and that does a controller and it has encryption and all that, so you could actually check them into GitHub, and that seemed to work pretty well. But it's the same thing. If you lose your key, right, you're screwed. So that's why the KMS is better.
That's why I like AWS Secrets Manager or the Google Secret Management that they have. You can also set up rotation, so secret's forced to rotate within 30 days, and then it automatically rotates that secret for you. So, that's the one thing. People set their secrets, then don't rotate them.
Yeah. All right. Well, I think that's it. So we'll let you all enjoy your evening. I don't know if we'll see you in person next month, but we hope to soon. So have a good night, y'all.
Thanks, everyone. Appreciate you having me.